So an official welcome. My name is Liz Woodham and I'm a member of the NRICH team here in Cambridge. And I'm here with my colleagues, Charlie Gilsdale, and Ems Lord. Ems is the director of NRICH. So we'll be working with you this afternoon. We're very grateful to Trinity College here in Cambridge who give us funding so that these events can take place without you having to pay. The idea of this afternoon is that we're going to introduce you to our new, what we call features, and we're super excited about this. We're going to have a good explore of our Mathdoku resources. Charlie and I are going to have a little go together. We're going to encourage you to participate using the chat as well. So we're really looking forward to it. Charlie, I'm going to hand over to you because I think you're going to share your screen with us.
Okay, can you see that, Liz? And you can hear me?
Okay. Yes, I can. That's brilliant. Thank you.
Okay, so so this is slightly unusual because both for primary students and secondary students, for primary teachers and secondary teachers, we have put Mathdokus, the mathematical Sudokus, in our features. So this is for everybody. I'm going to click on the primary teachers, but I could have clicked on any of these four lozenges and it would have taken us to the appropriate feature. And when I click on the feature, you'll see here that there are some 3x3, 4x4, 5x5, and 6x6 Sudokus. And what we thought we would do is we would work through one of the 4x4 Mathdokus. I think I just call them Sudokus. One of the 4x4 Mathdokus, and then give you a chance of working on a 5x5 one. And for each size grid, there are 12 different Mathdokus. So if I click on the purple cog, you'll see that there are 4 puzzles 1, 2, 3, 4, at each of 3 difficulty levels. And of course, with students, you're likely to start with easy examples, but because we're doing this with teachers, we thought that we would just dive in at the deep end and have a more interesting afternoon and more of a sense of achievement when we work on the difficult ones. So Liz and I are going to work on difficulty level 3, puzzle number 1, just to demonstrate how all this works. And then we're going to give you a chance of working on a slightly bigger grid. So, so the way this thing works is a bit like a Sudoku. Because it's a 4x4, you've got to use all the numbers from 1 to 4 on every row and on every column. And so you can't repeat any number on any row, and you can't repeat any number on any column. And there are 4 types of clues. There are some which tell you what a couple of, what some cells add up to. So here you can see there's a 4 plus, and it's in this cage, which contains these 2 cells. So those 2 cells must add up to 4. These 2 cells, which are part of another cage, have 2 numbers. When one is divided by the other, the answer to the division is 2. Here there's an L-shaped cage telling you that these 3 cells, when multiplied together, come to 24. And here's another multiplication cell. These 3 cells multiplied together give you 8. Here, very kindly, we're being given the answer. The answer is 1 to that. So we can just fill a 1 in there straight away. And here there's a couple of cells. Their difference is 3. So you can have plus, minus, multiply and divide. And there is some help, but there's a help button here. And initially, when you click on the help button, it tells you what cell we are able to fill in next. It may not be the only one that we can fill in next, but it is one that it is possible to fill in, but it doesn't tell you how. Then you can click again and you can find out what the hint is. So in that spirit, Liz and I are going to talk to each other by pointing out to each other when we think we know what can be put in a cell, but we're not going to tell the other person what we're thinking. And so the other person needs to sort of figure out what might be possible. So I don't know whether you want to start, Liz, or or you want me to start.
Okay. I think, Charlie, that I could fill in the cell which is in the 3rd row, far right, so next to the 1 on the right-hand side.
You think you can fill that cell in? Okay. I was hoping you weren't going to suggest that. Okay. 18. Oh, wait a minute. 18 is 3 times 6.
Yeah.
And 6 is 3 times 2. Oh, okay. So the only way of getting 18 is going to be 2 times 3 times 3.
That's what I thought.
And the 2 3s can't be on the same row and they can't be on the same column. So I think that's going to have to be a 3 and the other 3 is going to have to be there. And that's going to have to be a 2.
That was my reasoning as well. Yeah. Okay.
Okay.
I like the way I surprised you, though. That was good.
Okay, I think you can fill that cell in, Liz. Can you figure out how to do that one?
Right. 24. So 24 times. So I know that those 3 cells in that cage there multiply together to make 24. So 24 is 2 lots of 12, which is 2 lots of 6. So I reckon 2 times 4, 2 times 3 times 4. Hang on, let me just double check that. 2 times 3 is 6. Yes, 6 multiplied by 4, 24. So 2 times 3 times 4. So I know that that one's got to be a 3, Charlie, because I couldn't have a 3 on the same row where we've already got a 3. Oh, you're looking really. Is that not?
Ah. Okay, so you're saying.
Think about it differently.
Yeah. Okay, so you're saying there's a 3 on that row. So you can't have a 3 here or here.
Yeah.
And 3 has got to be a factor of 24. And because it can't go here and it can't go here, it's got to go there.
Yes.
My reasoning was slightly different.
Oh, go on. What was yours?
8 times, I think it's got to be 1 times 2 times 4.
Nice.
So one way that we can write this down is that we can have placeholders. So down here, I can write 1, 2, 4 as placeholders. I'm not going to put a 1 here because I know it can't be a 1 because there's already a 1 in that column. And I'm not going to put a 2 here because there's already a 2 there.
Yeah.
But they're placeholders. But whatever happens, I'm not going to put a 3 is not a factor of 8. So I'm going to change that. I know that that's a 3. Okay.
Okay. Yeah. Nice. Okay. Could we add in, Charlie, just the other possibilities for that 24 cage, please?
Okay, so 24 is 3 times 8. So this has to be either 2 or 4.
Yeah.
And this has got to be 2 or 4.
Thank you.
Okay, so by similar reasoning, bottom row, we've used 3 and 2.
Yes.
So there's only, again, I'm going to put this as placeholders. We don't know what order, but I think the only thing we can have here, 1 and 4, which have got a difference of 3, because we've already used 2 and 3. So we don't know where they're going to go, but that's going to have to go.
I'm going to use a very helpful comment from Valley on the chat, Charlie. And I'm going to say, don't look at the chat if you don't look at it, don't look at it.
I'm not.
Good. So I think, Charlie, I know which number goes in the first row, second column.
Over there?
Yeah.
Okay, 4 plus. Okay, so 4 plus, it can't be 2 and 2 because I can't have 2 identical numbers on the same row. So it's got to be 1 and 3. Okay, it's got to be 1 and 3. And I'm not going to be able to put a 3 in the first cell. So let me click on that. So this has got to be a 3 and this has got to be a 1. And that's quite useful because now I can fill these just using usual Sudoku logic, which is I can't put a 1 here because I've got a 1 there. So that's got to be a 4. And this has got to be a 1.
Interestingly, Charlie, can I pause you there? Valley on the chat, she also used, I think, Sudoku logic to fill in the 3. Whereas you looked at the cage value, I think Valley was thinking, okay, there's got to be 1 more 3 in this grid. Where can it go? And that's the only place it can go. So there's another alternative there as well. All right, so I think we can complete the first column, Charlie.
Yes, this has got to be a 2.
Yeah.
And this therefore has got to be a 4. And this therefore can't be a 1, can't be a 4, so it's got to be a 2.
Yeah.
And this can't be a 2, so it's got to be a 4. And this can't be a 4, so it's got to be a 1.
Oh, we're on a roll. We're on a roll.
So this must be a 2. And this must be a 4. And we can just check, and we can check answers.
Yay.
We're perfect.
Yeah. Good teamwork, though. Good teamwork. Well, actually, was that teamwork? I liked the way you were challenging me to, you know, I like the way that you were saying, I think I can do this cell. How do you think I could do it? And I also love the way that we actually came up with some different ways of filling in a particular cell. I think that could provoke some really rich discussion in the classroom. So Charlie, do you think that might have been a little bit too easy for our participants, or?
Well, I think given that there are lots of them and they can help each other, I think we're not going to do anything from now onwards. So this time I'm going to go to secondary students and I'm going to click on the feature, and they're the different Sudokus. So math dokus. Okay, so this time for everybody, we're going to give you a 5x5 to try. And we've decided that a really nice one to try is a difficulty level 3, puzzle 1. And the invitation now is to use the chat to suggest either which options, some placeholders you want me to add. So I'll be your scribe. But if you think you can fill one in, then in the spirit of the help button that we've produced, tell us which one it is that you think can be filled in, and then everybody else can have a go at trying to figure out what your logic might be. I hope we've explained that well enough. Okay, I've got my chat all ready.
Great. So I guess we were thinking about columns going from left to right, Charlie, weren't we?
Yes.
And actually slightly counterintuitively, possibly. I think I was thinking about rows, that numbering the rows from top downwards.
Yes.
Were you?
Yes.
Okay, so that's one way of describing potentially.
Okay, so somebody has said, can we fill in the 6+ column with 1, 2, 3? Yes, we can. So what Val, I think, is suggesting is that the only way to get a 6 when you're adding numbers is to, oops, sorry. I want this instead of, the only way you can get a 6 is by adding the 3 smallest numbers.
I wonder whether any future posters, would you mind not telling us which numbers you think should go in the cells? Just tell us which ones you think can be filled, in the spirit of the way Charlie and I were doing it earlier. That gives us all a chance to think about the reasoning ourselves. Okay, we've got a suggestion about the second and third boxes on the first row, Charlie. Yeah. So I wonder if you haven't thought about those 2 cells, what could we deduce from that?
Okay, so Catherine has said it's got to be 1 and 3.
Yeah, I think I would agree, Catherine.
Because, so we haven't done the 6x6 Sudoku. And of course, when you do this, what's nice about it is that the 3 divide gives you 2 options, because you can have 6 and 2. But for here, we can only have 1 and 3. There was a suggestion that in the bottom row, the 2 divide had to be 2 and 4, but I'm not convinced that it can't be 1 and 2, can it? Because if you had a 3 in the bottom right corner, you could have 1 and 2 along here, perhaps. So
I think I'm following your logic, but Catherine, if you disagree with us, please do post. Please let us know.
Yeah.
We've got a suggestion about the 8+ cell. Oh, Catherine does agree. Okay, thanks, Catherine.
Okay, so the 8+ cell, I think there is more than one possibility, because you could have 1, 2, 5, and you could have 1, 3, 4. But
I guess we do know that it can't be a 1 top left, perhaps.
True, but in terms of the 3 numbers that it could be,
yeah.
Could be. But here, I don't know, am I allowed to give a little bit of help here? If you know that these 3 numbers are up to 8, we can also work out what these 2 numbers add up to.
Ooh, interesting. Yeah, don't say any more about that, Charlie.
No, I thought I'd stop there. Okay, while people are thinking about that, a few people, Sue and Val, have said, or it may be I can't read it. That in the far right-hand column, because we've got 1, 2, and 3 here, we must have 4 and 5.
Yeah.
And we don't know what order. And David has also said that
just going to say that the 12 plus, yeah.
The 12 plus has got to be 4, 5, and 6.
Yeah.
Oh no, sorry, 3, 4, and 5.
3, 4, 5. Yeah, we don't have a 6 option. 3, 4, 5. Again, right. We don't know what order, but there's no other way of making 12. Yeah, with addition. Yeah. Okay.
Which means, Liz, that if
yes.
we're going to have a 3 somewhere here, so we can just click on this 3 and remove it.
Absolutely, we can rule out 3 from that cell, can't we? Good thinking. Let's have a look. What other suggestions have we got? Oh, okay. In the 2 and then last row.
Okay, so I'm going to go back to my.
Oh yes, first column.
Because I know that they add up to 8, I can work out what these 2 add up to. And once I know what these 2 add up to, I can then use the 3 minus clue to help me work out what pair of numbers goes there.
Okay.
So if anyone would like to explain.
Yeah, Hazel has posted, Charlie.
Yes.
She says that the 3 minus cage, the 2 numbers there must add up to 7, but also have a difference of 3.
Okay, so they must add up to 7 because we know that the whole column adds up to 15.
Because we know there's 1 of each number, exactly.
1 plus 2 plus 3 plus 4 plus 5 in whatever order will add up to 15. So if these add up to 8, these must add up to 7. And now we can work out, there are only 2 ways of getting a difference of 3, 1 and 4 and 2 and 5, but only one of those gives us a difference of 3.
Yeah.
So that's got to be either 2 or 5, and that's got to be 2 or 5.
So we don't know which order yet, but Catherine is suggesting that the bottom number in the 8 plus cage must be 1 or 2. Let's have a look at that row. So looking at the 3rd row.
That's going to be 1 or 2.
I can see that logic, yeah.
We know that's going to be 3, 4 or 5 there. Yeah. 3, 4 and 5 there.
Oh, I hope I'm going to pronounce your name, Treza, the placeholders. So what Charlie is doing is he's selecting, Charlie, would you mind just drawing attention? That's it, brilliant. So you can toggle between these 2 options in the interactivity. The lower option allows you to enter more than 1 number. So those are the green placeholders, and the option at the top will allow you to enter your final decision. I hope that helps.
What we haven't done, Liz,
is
shown anybody how the help button works.
Oh, that's a good idea. Should we do that?
So when you click it the first time, it shows you which square can be solved. And in this case, it's telling us that we can fill the bottom right hand square. So this corner square appears with a yellow frame, and it's telling us that there's enough information to fill that one in. Possibly we should have pointed out that there is a sentence here which says there is always a way forward that can be worked out. So there's no need to ever guess. Liz and I saw this earlier, and we had no idea what we didn't click on the give me a hint about, but you might like to think about what information is there that already that might help us fill that cell in. When we did this earlier, it was about 10th cell that we filled, not the first. So don't worry if you can't work out what's going on. Right, I'm going to go back to the chat.
Okay. Thank you for all your suggestions. And I appreciate how frustrating it must be for some of you who are posting suggestions and we're not paying any attention. It's quite hard to keep track and to choose one. Charlie, have you 8 plus must be 1. Cannot be 3. 1. So it must be 4. There are several comments about the 8 plus cage, Charlie.
Okay.
We've ascertained that the 3 minus cage has got to be 2 and 5.
Oh,
so I guess therefore
this can't be a 2.
It can't be a 2. Yes, precisely.
Okay, so that's got to be a 1.
So that has to be a 1.
And so this one has to be a 2.
Nice. And so I guess.
So we can get rid of the 2 from here and the 2 from here.
Yes. Apologies to those of you that have been posting that and we hadn't noticed. So I wonder, Charlie, can we fill in the other 2 cells of the 8 plus cage?
Okay, so this has got to be 3 or 4.
It's got to be 3 or 4 because we can't use a 5 or 2. Yes, we can. We can fill that top left.
Because those 2 cells have got to be a 1 and a 3. So we can't have a 3 there.
Yes, and we've had a couple of posts on the chat to that effect as well. Yeah.
So that's a 4. And so this must be a 3.
Ooh, so top right, Charlie.
That can't be a 4. Just normal Sudoku rules because we've got a 4 there.
Yeah.
And so this can't be a 5.
Okay.
Okay, I'm going to be quiet.
Any other suggestions? Let's have a look at the chat.
Okay, so Val is saying we can fill in the 1 minus cage at the top here.
Yes, specifically, yes, that cell at the very top, first of all.
Okay, so that has to be a 2.
I think so, because we know that the 1 and the 3 are already in there.
And so given that the cage says 1 minus, this could be the difference between 2 and 1 or 2 and 3, but we can't have a 3 here because there's already a 3 on that row. So that's going to have to be a 1. Yeah?
Absolutely. I agree with your logic there. We've got some suggestions that possibly then that helps us with the 2 divide cage on the bottom row, Charlie.
Okay. So normally there are 2 ways of getting a 2 divide, 4 divided by 2 and 2 divided by 1. But we can't have 2 divided by 1 because we already have a 2 and a 1 there. So we can't put either a 2 or a 1 there. So it's going to have to be 4 and 2. And we already have a 2 there. So it's going to have to be a 4 there and a 2 there. So that just sort of normal Sudoku rules helps us do this one.
Absolutely. Okay. So let's have a look.
We haven't thought about this 3 minus at all.
No, we haven't. So how can we get a difference of 3? 5 and 2, 4 and 1?
No, you can't have 5 and 2 because we already have a 2 in the 3rd row, sorry, in the 4th row and a 2 in the 5th row. So we wouldn't be able to put 5, 2 in any kind of way. So it's going to have to be 3, 4, 1.
I agree. And because we've got a 4 in the bottom row already as well.
Right. So that is why we could have filled this cell in earlier. That you couldn't, if you have a difference of 3, you can't have a 3 in any of these cells. If you have a divide by 2, divide and get 2, you can't have a 3. So the only place you could put a 3 in the bottom row
is there.
So shall we see what the hint says?
Yeah, let's see what the hint says. Give me a hint about this square.
Is there a number that can't possibly appear anywhere else in that row? Yes. Because you can't get a difference of 3, which involves the 3. So you can't put a 3 there or there. You can't put a 3 there or there. So you have to put the 3 there. Haha, that's nice.
That is nice, isn't it? So it's interesting, isn't it? Because the hints in our interactivity are obviously that they're based on a particular route through the Mathdoku, and they happen to be not the route that Charlie and I and you participating have taken, but it does offer a definite sort of hook, a definite support if we were totally stuck and couldn't go anywhere else.
Yeah. Okay, so I'll just fill in when it's just normal Sudoku rules, shall I?
Yes, do. Yeah, and we've ascertained what those two are. Great. So surely we can do some narrowing down now. Yes, what about in the 3 divide at the top there, Charlie? Oh, yes, thank you.
Okay, so 3 divide, we've already got a 1 in that column. So we can get rid of that 1. So that's going to be a 3, and that's going to be a 1.
Mm-hmm.
There's 2 minus. Okay, we don't know. And there's 3 minus. So
we can narrow down some possibilities in the 12 plus cage, I think, Charlie, on the left of that cage.
Okay, so if I click on that, I can get rid of the 3 there, because there's a 3 there already. Mm-hmm. Oh, I can get rid of the 4 as well, because there's a 4 there already. On this cage, I can get rid of the 4 as well.
Would you mind putting the 5 in?
The 4 can only go in this cell.
Good point.
The 4 can't go there, and the 4 can't go there, so the 4 has to go here.
Yes.
And obviously, there's only a 5 there, so there's got to be a 3 there.
Okay.
Okay, I think the rest is reasonably straightforward. 2, 3, 4.
Yeah, so Charlie's just using normal Sudoku rules now, I presume, Charlie, just to look at the digit that is missing, the number that's missing from that row or column.
And we can check our answers.
We check our answers. Oh, well, that's good. Thank you for your help, those of you participating. I don't think we would have done it quite so quickly without your help. So Charlie, shall we have a little chat about why we might use Mathdoku in the classroom? And then we've got something else to show you. So I guess, what have we been doing as we've been working on those Mathdokus? Do post in the chat if you've got something particular you'd like to share. I mean, I guess we've been doing a lot of mathematical reasoning. We're reasoning in the context of, number bonds, of factors and multiples. So we're I guess developing fluency potentially with those facts that we have, and why else might we use this? Any other suggestions? Those of you participating, do pop some ideas in. I like the fact that it feels quite playful. It's got that feel that actually I can change my mind. I can, I guess it requires me to work quite systematically, ultimately. Oh yes, we've got some great suggestions here. Communication, yeah. Fab. Yes, the thing about the children not guessing is exactly what you drew attention to, Charlie. The fact that there is always a cell you can fill using completely sound reasoning. Yeah. Engaging.
We tried to replicate. I'm not sure how successful we were, Liz. We had a colleague called Vicky, and she used to do the crossword in the common room during the lunch hour with a colleague of hers. And the way that they used to do the crossword together is when they thought that they could answer one of the clues, they would tell each other, which is why we set up the math dokus we have, where it's like shining a torch on the cell or the cage that can be solved. And so knowing it can be done means that that is where you focus your attention. So it's a first stage, or it's a sort of a low level of scaffolding. And then if you really can't figure out what's going on, and we couldn't when we rehearsed this one with that bottom right one, and then later on we thought, oh yes, of course, kind of. Well, of course is not the right word, but trying to get students to do the same, it seems to me, if they can be slightly more disciplined than Liz and I are, that seems quite nice. And it reflects sort of the NRICH philosophy, which is that when we ask students to publish solutions, we often make a distinction between publishing what the answer is, which is rarely very interesting, as opposed to publishing the solution, which is sort of how did people go about solving the problem that led to the answer. So sharing the approach and the thinking and the strategies is much, much more interesting than knowing that the answer is 27 or 42 or 5x plus 2. And so getting students to think and talk to each other in that kind of way would be really nice. And that's what we tried to model, but it didn't always succeed.
I think somebody's made a good point as well about resilience, which I don't think you mentioned there, Charlie, that knowing, I guess that links back to the fact you don't have to guess. If you know that there is a cell that you can fill in, it's that little bit of motivation. Some of you have mentioned motivation, that little bit of motivation that encourages you to keep going. We hope. Charlie, were you going to say something?
And somebody's talked about safe place for mistakes, and it's also sort of it's sort of slightly messy as you go along. It's a little bit like, well, it could be this or that, and sort of it's a safe place to be uncertain, I think, is perhaps how I would describe it. Oh, we're not sure quite. Oh, these three add up to 8. Well, oh, those two must add up to 7. Oh, okay, that's interesting. Oh, and when you put that together with that, so making links and connections. And I suppose the other thing I really like about it is that there isn't just one way of going up. When you and I solved this puzzle earlier, I think both math dokus that we've done, we did them differently. The route to the final answer that we took was different. And that seems quite nice too.
Yeah. Absolutely.
Yeah.
Just on a practical note, Charlie mentioned how we kind of tried to model the way you could use it in the classroom. Just in case, oh, Helen, a good question. Yes, there is always a unique solution in the math dokus on NRICH. Yes. Just let me share my screen and just let me show you that you can print the math dokus, and just let me show you how you can do that. Sorry. There we go. Charlie, can you see my web browser?
Yes.
Great. So let's go to, it doesn't really matter, as Charlie said, that the primary teacher page and the feature again. And if we go into any of the math dokus, doesn't matter which one, if you click on the purple cog and you saw Charlie doing this to change the difficulty. You can also click on the printable button, which takes away the colour. So you've got a black and white version. Then if I just scroll up again, if you click here where it says hide menu, you can get rid of all that stuff on the left, which gives you a relatively clean page. And then you can use your browser settings. If you go to the file menu, sorry, your browser menu, if you go to the file menu and then print, you could print off that way in case you prefer to work on paper rather than using the interactivity.
So Liz, I think now's the time for the final present.
Yep, I think so too. So you've appreciated that. We've got Mathdoku grids up to 6 by 6. They do get pretty challenging. But
yeah, I think the 6 by 6 difficulty level 3 took us at least 20 minutes to solve. At
least, yes. But we'd like to give you a sneaky preview, if you like, of our editing, our Mathdoku editor. That's the best way to describe it. So once your students are super familiar with the idea of Mathdokus, they've done plenty, you might like to offer them this. I'm going to just change my browser window. You might like to offer them this idea. They can create their own Mathdoku. So we're going to very quickly show you how this editor works, practically speaking. It's not yet live on the NRICH website, but we will put it up fairly imminently, and we'll tweet about it so that you know it's there.
And it'll appear on the feature pages as soon as it needs some final tweaks to it, but it's nearly ready.
So what we've got here is a tool through which you can create your own Mathdoku for somebody else to solve. So what we're going to do is we're going to have a go at creating one, so that we're hoping that you'll get the idea of using the interactive itself and a bit of an idea of the kind of things to think about. So you'll notice that in a similar way to our actual Mathdoku, you've got a number of options. So what you're seeing in grey here are the possibilities for that cell. So what we could do, probably the easiest thing to do, Charlie, do you think, is to populate the grid so we've got the final solution, and then we can put some clues on top of it. Should we do that?
Yeah, so the final solution's got to be a Latin square where the numbers don't repeat themselves on any row or any column. So one nice easy way of doing that is to put 1, 2, 3, 4 in the top row, and then 2, 3, 4, 1 in the next row, and then 3, 4, 1, 2, and finally, you've done 3, 4, 1, 1.
Thank you.
Somebody's still got their microphone on in the background somewhere. And then finally 4, 1, 2, 3. And this may be rather predictable, but we could, if we wanted to, swap the numbers from one column, the whole of one column with another column, and a whole of a row with another row, and jumble them up. But I mean, we can do that later if we've got time, but let's move on, Liz.
Yeah. So currently, every single cage is only one cell big, as it were. So the numbers in the blue boxes are literally reflecting the number that it has to be. The blue cells are what the solver will see. So what we need to do now is create some cages and alter what the user will see so that they are clues to be solved. When you see what we're doing, that will all make much more sense, I promise. So, Charlie, this strikes me.
We need to remove a few walls, don't we?
We need to remove a few walls. So looking up here in the top left-hand corner, this strikes me as a potential cage. If we get rid of that border and get rid of that border, we've now created a cage consisting of those 3 cells. Now, you can see how the blue number, the blue clue, if you like, has changed automatically. It currently says 5+, obviously because those 3 cells add to 5. Now, we may not want to leave it as 5+ or 5 add. We may want to give an alternative clue. So Charlie, I guess what we could do we want to give a clue that narrows down the options a bit, potentially? We could, if I click on this, it scrolls through the 4 different operations. Now, in this case, you will notice that the takeaway, the minus, is a bit nonsensical because there are 3 cells. So we're going to ignore that one. I quite like 4 times for that, Charlie, because
4 times is really nice, because it could be 1 times 1 times 4, or it could be 2 times 2 times 1.
Yes, exactly.
Which makes it more difficult. So can I just clarify, not that what Liz said need to clarify, what the students are going to see, or what the users are going to see, is what's in the blue square, in the blue highlighted boxes. So like Liz said, all the numbers are appearing now, but we're going to get rid of most of them because that makes, there's no challenge. We're going to get rid of, we're going to demolish some walls, create some cages, and what's in the blue box is going to be the final Mastoku. So yeah, 4 times I think looks much more interesting.
Yeah.
Seems much more interesting than the plus.
Alexandra, that's a really good question. How do you know that you're creating a grid that is solvable? You don't until you have a go, is the short answer.
But we're going to try and make it as difficult as possible for us, for ourselves now, and hope that we can solve it.
So what do you think, Charlie? What I quite like, I guess it will be quite nice, in my view, to have a range of operations on the Sudoku. I wonder whether we could. Why don't we have why don't we have this 4 and 1? Why don't we change that into a division?
Okay. So here you can have any of the 4 operations, because when you have 2 cells, you could be adding them, you could be subtracting them, you could be multiplying them, or you could be dividing them. When you have more than 2 cells, you will still get the option of subtraction and division, and you need to ignore it. This is one of the tweaks that Oscar's working on at present. We're hoping that it'll be removed, because you can't have a subtraction clue when you have more than 2 cells in a cage. You can't have a division clue when you have more than 2 cells. Mm-hmm. Okay.
So what else do you reckon? Could perhaps where could we pop an addition? I wonder. Let's see where we could. Yeah, there. Valley's on my wavelength. Also suggesting an addition. Do you know it was quite? Do you remember in the previous grid we tried there was an 8?
A 3, 4, and 1 and up to 8.
3, 4, and 1 that make 8. Should we try that? Should we go across a row, or should we go around? Because we could do something like this.
Yep.
Yeah. What else do you think? Let's put a few more in.
I do like these L-shaped ones.
Yes. Okay.
Top right, can we do 3,
Right.
4, 1 and do times and make it 12? Is that?
Yeah. There we go.
So all you're doing is clicking on the blue.
Just clicking on the blue and it rotates through the options.
The computer knows which numbers we've selected for those cells, and it gives us a chance of putting a clue which involves either multiplication, subtraction, division, multiplication. We're not having to calculate anything.
That's right.
Okay.
Right. What about, so we've still got a few individual cells down the bottom here. What we could do is do another 12 times here.
Yeah, because 12 times can be 3 times 4 times 1, or 2 times 2 times 3. So it's quite nice having clues that, whereas the 4 divide, we've made it slightly easier because it's got to be a 1 and a 4, but that's okay.
It's nice having a mixture of both though, I think, isn't it?
Absolutely.
Okay, so here we've got 2 cells that are at the moment, they're just individual cells. Do we want to add a clue? Do we want to join those together?
Yes, please.
Yeah, what do you reckon? Have we got one of every, we haven't got a difference yet. Should we make it a difference?
Okay.
Yeah, difference of 1?
Yes.
Okay, so are we happy?
Can I just say something, Liz? Sorry.
Please.
When you introduced this,
yes,
and you talked about being able to create our own Sudokus, what we have in mind is not necessarily that the teachers are going to create Sudokus for their students, because in a way you might as well use the 48 that we've produced. This really is something that you might want to offer students because they may really enjoy creating as difficult a Sudoku as they can to give to their classmates, to their friends. What we're imagining is that once they've had a go at the ones that we've created, they might want to have a go at creating some of their own.
Exactly. Yeah. Sorry, I maybe didn't make that explicit enough. So I think once you're happy with your Sudoku grid, going back to the point earlier about how do we know this is solvable, how do we know this is a unique solution, this is when we get a chance to find out. So by clicking on this share button, we get given a funny looking code. And what we're going to do with that is we're going to put that code on the end of a URL. Now, I appreciate that you're watching this here and now. This may look a little bit like, you know, magic. But when this is published on NRICH properly, we'll make sure we put proper instructions. So
we're going to do a video like we've done for the Math Dokus. Liz and I will do it where we'll...
right, what we need is we need the first bit of this URL up to the question mark. So I'm going to copy that. I'm going to pop that in a new window. And then we're going to go back to our... I'm going to copy the code. This is when I do this all wrong and it's going to look terrible. At the end of this, I need to put code equals, paste that code, fingers crossed. Okay. So now we need to figure out whether we can solve this. And obviously we know what the numbers were, but let's ignore that. So any suggestions on where we could start?
And also ignore that it says difficulty 1, puzzle 1.
Yes.
That's one of the tweaks that's going to be removed soon.
Thanks, Charlie.
Okay.
So we can... Oh, now, you know, look, Charlie, I'm not able to, I think... Oh, I know. Oh, wait a minute.
You're not able to what?
I'm not able to fill any cells in. Oh, I am. Sorry, I just haven't highlighted a cell.
Yeah.
Good, sorry. So where can we go here? What can we put in? Do post in the chat if you've got some suggestions. I guess in the interest of, start with the 4 division. That's just what I was going to suggest in the interest of speed. So we know the only way we can get 4 here is if we, oh, hang on a second, my Zoom menu has handily just moved over that, there we go. So we can have here a 4 or a 1. Okay. Right, we've got a suggestion for the times 4. It has to be 114 or 221, okay.
Ah, but if you have a 1 and a 4 already in the second column,
oh,
you're not going to be able to put a 1 or a 4 in that second cell in the top row.
Nice, Charlie. So actually we can straight away fill in this cage, I think, can't we? So this is we're gonna have to go for the 221 option.
Because we can't do 4, 1, 1.
And because it's 2, 2, 1, we know that the 2s have to be in this position because, of course, they can't be in the same row or in the same column.
Yeah.
Okay. Nice. What else have we got? Second row, remaining cells are 2 and 2 or 3.
Is that second row or first row? Oh, no, sorry.
I'm not sure. I'm not sure about that one. Oh, we can possibly fill this one in though. Yes. I think I agree with Valley.
Yes.
Yes, it has to be a 3 because we know we've got a 2, a 1 and a 4 in the column already. So that means these 2 have got to sum to 5. Oh, Hazel's offering us 12, must be 3 times 4 times 1. Because we know we've got 3 and a 4 up there. Yes.
So do you want to put the 3 and the 4 as placeholders?
Let me do that because we don't know yet which way round they are, but we can, as Hazel says, definitely put the 1 in. Right. I appreciate that we're almost run out of time. Top row remaining cells for it. Yes. Okay. 8 plus will have to be yes. So we know that this cell has got to be a 4, I think. Which means we can backfill here, I think.
Yes.
3 and 4. Thank you to those of you who are able to stay on.
And the 8 plus clue, we've already got 7, the 3 plus 4, so there's only a 1 missing.
Thank you.
Which means that you can fill in the cell to the right, to the left and below.
So we can fill in, oh yeah, good point. We could do this because we can't have a 1 there, which means that's got to be a 1. And I think we can also fill in this column now, just using Sudoku rules. There's a 2 missing there. Right, we need to make 6 here, I think. We've got 2 numbers to multiply to make 6.
And you've got 2 and 3 missing. So yeah, I think the rest is going to fall into place.
Yeah. So hopefully that's right. Yeah, we're gonna need a 4 and 3 there. I'm going to quickly put the 3 and the 4 and let's check. Okay.
Oh, wow. Yeah, I didn't realize you got that feedback.
So we did, in that case, create a solvable Sudoku. Thank you all very, very much. We've rushed on. I'm afraid, Hazel, there isn't a way to quickly print multiple levels, but it's something that we have on our to-do lists. So we're aware that will be useful. We hope that you might be able to join us for our next webinar, which is next month. I think Ems has already shared a link to our feedback form. We really appreciate any feedback you give us. So do take a moment to fill that in. We really hope to see you on a future webinar. Don't forget to follow us on Twitter or sign up for our email newsletter if you don't already do so.
Is there a page, Liz, where we're going to upload a slide with some information?
Yes, thank you for the reminder. So if you go to NRICH.live, sorry, NRICH, this I shall try and demonstrate rather than, there we go. This URL, so after the nrich.maths.org part of the URL, if you put nrich-live-oct-2022, this is where we will put a recording of today's webinar, along with
wait, Liz, this is going to be difficult to remember. Can we get through from the events link?
No, not at the moment, but we will be able to. So,
okay. Can you get to the September one through the events?
So I've gone to the events page, which is where today was advertised. We can look at the previous NRICH Live events. And so in due course, we will add in a link there. Yeah, good point. Thanks, Charlie.
That might be easier than
remembering the URL. You'll also, we'll upload 2 PowerPoint slides, the second slide of which will give you a few links that are more generally useful, we hope, if you're exploring NRICH. Thank you very much. Thank you for participating. We really appreciate it. As I say, we hope to see you again next time. Charlie, is there anything else you'd like to say?
Well, only that we have suggested students might want to send us solutions. And when we've asked, we're suggesting, please don't send us answers. We're getting completed math dokus are going to be of very little interest. But if, for example, anybody gets really stuck and then finds a way around it, it'd be fantastic to have a screenshot of what they've got and how they sort of got out of the trap, how they managed to figure out a way forward. That would be really interesting. Sort of strategies that people came up with that they thought that they, which seemed innovative or that they hadn't seen before, and that are worth sharing. It'd be lovely to have a collection of these. So do encourage your students to send us strategies and solutions rather than just completed math dokus, which we're unlikely to publish.
Thank you, Charlie. I've totally forgotten that. Wonderful. Thank you all. Sorry again that we've run a little bit late, and we look forward to seeing you on a future occasion. Bye-bye.
If they're not too busy doing math dokus.
Good point.
Bye, everybody.